Hey, so in this module I introduced object-oriented programming, I introduced classes and structs, and in this lesson I also introduced enumerations, and in previous examples I also talked about namespaces briefly. So at this point I want to summarize the accessors for you. Let's say I have an object or an instance of a class or a struct. Which accessor are we going to use? Well, we're going to use the dot operator. So we do the object name, dot, and then the member or the member function that we want to access. If we have a pointer to an object, whether that is on the stack or on the heap, then we use the arrow operator, and you can see an example again in the right column. If you remember, we use the arrow operator instead of doing dereferencing, followed by the dot operator. We use the scope resolution operator often in C++ with structs, classes, enumerations, and namespaces, and we do that to qualify some identifier. You can see some examples to the right. We have std, the scope resolution operator, and cout. That of course refers to the standard namespace. We have fmath, some math library, the scope resolution operator, abs, that will be a static member function, which will return the absolute value of something. And then we also have game difficulty, and we select hard. And of course that is an example of an enumeration, and you'll be qualifying that especially when you use scoped enumerations. Okay, we specialize or qualify the name of something, some identifier, to a particular type, because remember we can have multiple functions of the same name, or multiple scoped enumerations with the same name, for example, or maybe for some reason you use two different math libraries, and both of those may have a static abs function, so which one do you use? Well, you have to specialize or qualify the type, and in that way you specify exactly which one you want to use. We'll see more examples of qualifying an identifier to a specific type in future lessons and examples. It's really useful to solve ambiguous errors, in other words to disambiguate your identifiers. I have a bonus example for you here. I'm not going to demonstrate all of the operators, we are familiar with them at this point, but there's one interesting case that I haven't covered yet. Let's say we have a variable in the global scope, so a global variable, and I have that same variable in main. So I'll just do a constant integer x is equal to 55 in the global scope, and in the main function, so within the body of main, I'll do int x, I'll set that to 2, and then I'll print that out. Now you can think for a second what will happen when I pull and run this. Pull and run and we get 2 printed out. Okay, so in other words it prints out the local x, and if I comment that out, of course we still have the global x now. And if I build and run, it should print out 55 now, so it's going to use the global x variable. But let's say for some reason in main we want to have access to both. Maybe the global x is not constant, so we can change it in main, or maybe you just want to print it or use it in main, or some other function. Again, main is just an example here. The point is sometimes you may want to have access to the local and the global variable. In some cases that may have the same name, which of course you should try and avoid to begin with. How do we access both? Well, you have to think about what it means to say that I'm declaring something in the global scope. The global scope is also referred to as the global namespace. You may remember that from previous discussions, because your identifiers that are declared outside of any class, function, or namespace exist in an implicit global namespace. So what does that mean? Well, that means here, console output, we can do x like this, and of course we are going to get the local one. Now, how do we access the global one from the global namespace? Well, you have to think about how we access a namespace, right? We can do something like std, the scope resolution operator, and cout to access console output. But of course that is global because we are using namespace standard at the top right here, so I don't need this. Now the global namespace doesn't have a name, so what we can do is you can use the scope resolution operator and the identifier without a name. Typically you would have a namespace at the front, or a class or a struct, an enumeration, but when we don't specify something specific before the scope resolution operator and the identifier, then we are referring to the global namespace. So this right here, scope resolution operator x, refers to this x right here. Build and run that, and we get 55 printed out. So that was just a quick bonus demonstration for you. I hope you found it interesting, and I'll see you next time.